Why does the very mechanism designed to ensure your survival sometimes feel as though it is threatening your very existence? As we gently unravel this paradox, allow your mind to settle into a state of quiet curiosity and restful learning. Anxiety is often misunderstood as a modern defect, yet it is actually an ancient, sophisticated software running deep within your genetic code. If you find comfort in learning these relaxing facts about the human experience, please gently click subscribe to join us for more calm nights of discovery. Think of anxiety not as a broken part of you, but as an incredibly sensitive biological smoke detector. Its primary job is to scan the environment for danger, prioritizing safety above all else. Sometimes this system works too well, interpreting a stressful email or a crowded room as a life-or-death threat. It is a protective mechanism that would rather sound the alarm 100 times for a false positive than miss a single real danger. This internal sentinel triggers the fight or flight response, flooding the bloodstream with energy to face a threat that, in the modern world, is rarely physical. This sensitivity varies from person to person and even changes throughout the day due to hormonal fluctuations. For some, the natural cortisol spike of the early morning brings a sense of urgency, while others feel the mind becoming active only when the world goes quiet. I invite you to share your experience in the comments. Do you tend to feel more anxious in the rush of the morning, or does it arrive during the stillness of the night? We're living through a period of history frequently termed the Age of Anxiety, a time where our biological alarms are constantly triggered by a complex world. Research indicates that anxiety disorders are the most common mental health issue globally, affecting hundreds of millions of people. It is a shared human experience that transcends borders, cultures, and languages. This ubiquity exists because fear was our species' first and most effective survival tool. The earliest humans did not endure the harsh prehistoric world by being calm. They survived by being constantly alert. Those who ignored the subtle snap of a twig did not last long, whereas those who treated every shadow as a predator lived to pass on their genes. Therefore, the worry you feel today is an evolutionary echo, a lingering survival trait inherited from ancestors who were masters of vigilance. This ancient mastery manifests in your body as the famous fight or flight response, a physiological cascade that is arguably the most sophisticated security system in nature. When your ancestors spotted a rustle in the tall grass, they did not have the luxury of time to debate whether it was a saber-toothed cat or merely the wind. Evolution favored the paranoid. In that split second, the brain initiates a rapid-fire sequence known as the HPA axis, the communication line between the hypothalamus, the pituitary gland, and the adrenal glands. This is not a subtle process. It is a biological alarm bell that floods the bloodstream with cortisol and adrenaline, instantly prioritizing survival above all else. Your body knows exactly what to do with this sudden influx of chemical energy. It diverts blood flow away from non-essential systems like digestion and the immune system, channeling it directly to the large muscle groups in your legs and arms. This is why your stomach often feels tight or unsettled when you're anxious. Your body has effectively paused your digestion to prepare you for a sprint. In the prehistoric wild, this mechanism was flawless. You either fought the predator or ran to safety, and in doing so, you burned off that massive surge of stress hormones, allowing your body to return to baseline. However, we now face what scientists call an evolutionary mismatch. Your biology hasn't changed much in the last 40,000 years, but your environment has changed drastically. The threats you face today are rarely physical predators, but rather abstract concerns, an overdue email, a difficult conversation, or a deadline. These modern triggers ignite the exact same chemical firestorm as a lion, yet you are usually sitting still in a chair. You cannot run from a mortgage, and you cannot fight a traffic jam. Consequently, that cocktail of adrenaline and cortisol circulates in your system with nowhere to go, creating the jittery, on-edge sensation we identify as anxiety. The speed at which this system activates is truly humbling. Research suggests that the amygdala, the brain's fear center, can process a threat in as little as 14 to 20 milliseconds. To put that in perspective, conscious visual processing in the cortex takes 300 milliseconds. This means your body begins to react to a danger before you are even consciously aware of what you're seeing. This is why you might jump back from a garden hose on the lawn before realizing it's not a snake. It's a feature, not a bug, designed to keep you alive at all costs. I'm curious if you have ever experienced this specific type of false alarm where your body reacted violently to a harmless object. Let me know in the comments what triggered your most memorable jump scare. This heightened sensitivity suggests that anxious individuals within a tribe played a critical role in the survival of the group. Evolutionary biologists have proposed the sentinel hypothesis, suggesting that in any given group of early humans, having a few members with a lower threshold for alarm was a strategic advantage.
While the heavy sleepers rested deeply, the anxious members of the tribe were likely the ones tending the fire, listening for the snap of a twig and smelling the smoke before the flames caught. In this light, anxiety is not necessarily a disorder, but a specialized form of guardianship. You are the descendant of the watchman who kept the tribe safe through the long, dark nights. To understand how this protective instinct became so deeply embedded, we must look beyond behavior and peer directly into the intricate physical architecture of the human brain itself. Deep within the complex folds of your medial temporal lobes, protected by layers of gray matter and bone, lie two small almond-shaped clusters of nuclei known as the amygdala. The name itself is derived from the ancient Greek word for almond, a humble designation for what is arguably the most powerful sentinel in the human nervous system. While the rest of the brain may be occupied with higher thoughts, poetry, or mathematics, the amygdala has only one primary function, which is to constantly scan the environment for threats, acting as the body's smoke detector that never sleeps, waiting to signal the presence of danger long before your conscious mind is even aware of it. This vigilance is made possible by the brain's unique wiring, specifically a mechanism often referred to as the low road of processing. When your eyes see a shadow or your ears hear a sudden noise, that sensory information is sent first to the thalamus, the brain's relay station. From there, the signal splits into two paths. The first path is the high road, which travels to the thinking cortex for analysis, a process that is accurate but relatively slow. The second path, the low road, is a shortcut that goes directly to the amygdala. This neural shortcut ensures that the alarm is rung milliseconds before you have physically identified what the threat is, allowing you to jump back from a snake in the grass before you even realize it is just a garden hose. However, this incredible speed comes with a trade-off that psychologists call the amygdala hijack. During a hijack, the amygdala declares a state of emergency and recruits the rest of the brain's resources, effectively shutting down the neural pathways to the prefrontal cortex, the center of logic and reasoning. This is why, in moments of high anxiety or sudden stress, it can feel impossible to think clearly or access your vocabulary. Your biology has prioritized survival over contemplation, rerouting blood and electricity away from complex thought and toward the muscles required for fight or flight. It is a brilliant system for surviving the wilderness, yet it can be overwhelming in the modern world, where threats are abstract rather than physical. I'm curious if you've ever noticed this specific sensation, where your logic seems to vanish in a split second. Let me know in the comments if you have ever felt that offline moment during a stressful event. What is perhaps most fascinating and somewhat sobering is the amygdala's capacity for neuroplasticity. We often think of the brain's structure as fixed, yet studies show that chronic anxiety can physically alter the architecture of this almond-shaped guardian. Just as a muscle grows larger with exercise, an overactive amygdala can undergo hypertrophy, physically increasing in size and density. As it grows, it becomes more sensitive, creating a feedback loop where it takes less and less stimulus to trigger the alarm, turning the brain into a hypervigilant watchtower that sees danger in safe places. This structure also serves as the librarian of emotional memory, working closely with the hippocampus to tag specific events with emotional significance. When the amygdala is highly active during an event, it stamps that memory with a chemical marker of importance, ensuring it is stored vividly and deeply. This is why we struggle to remember where we put our keys yesterday, but we can recall with crystal clarity a frightening moment from 10 years ago. The amygdala has prioritized that file for your future protection. Yet this emotional sentinel does not govern the mind alone, for it exists in a constant, delicate dance with a calmer, more rational partner located just behind your forehead. This partner is known as the prefrontal cortex, the master control center that resides directly behind your forehead and eyes. If we view the amygdala as the reactive, ancient sentinel scanning for danger, the prefrontal cortex is the sophisticated, modern chief executive officer of your neural architecture. It is the seat of logic, planning, and impulse control, representing the most recent major step in human evolutionary history. In a calm and balanced brain, the prefrontal cortex engages in a process called top-down processing. It assesses the raw data sent up by the amygdala and applies context and reason. When you hear a loud bang at night, the amygdala fires immediately, but the prefrontal cortex quickly analyzes the sound, identifies it as merely a shutting door, and sends an inhibitory signal back down to the amygdala, effectively telling it to stand down and cease the production of stress hormones. However, the state of anxiety is characterized by a disruption in this precise communication loop. Neuroscientists describe this as a functional disconnection, where the neural pathways between the rational cortex and the emotional amygdala are temporarily impaired. During periods of high anxiety, the amygdala becomes hypersensitive and hyperactive, shouting its alarm signal so loudly that it overrides the calming voice of the prefrontal cortex. This is often referred to as an amygdala hijack. It explains why, in the midst of a panic attack or a spiral of worry, it feels nearly impossible to simply think your way back to calm. The biological hardware responsible for rationalizing the threat has been effectively short-circuited, leaving the emotional brain to steer the ship without a captain. This structural dynamic also sheds light on why anxiety presents so differently depending on our age. Brain imaging studies have revealed that the prefrontal cortex is one of the very last regions of the human brain to reach full maturity. While the emotional centers are fully developed and highly reactive during adolescence, the regulatory machinery of the prefrontal cortex does not finish its development until a person is in their mid-20s, typically around age 25. This creates a distinct biological window during the teenage years where the engine of emotion is powerful and revving high, but the braking system of logic is still under construction. This developmental gap explains why anxiety in youth can feel so all-encompassing and difficult to regulate. The neural infrastructure required to dampen those intense signals is simply not yet fully online. Yet, even after full development, the strength of this connection is not fixed. The brain retains a remarkable plasticity, meaning the highways between logic and emotion can be reinforced or weakened based on how we use them. But these structures, whether the alarm bell of the amygdala or the executive desk of the cortex, are merely the hardware. For them to communicate, they require a complex language of signals to bridge the physical gaps between neurons. This brings us to the microscopic couriers that carry these messages across the synaptic divide, the chemical messengers known as neurotransmitters.
Imagine these molecules as tiny, precise keys drifting across the synaptic gap to unlock specific doors on the surface of the receiving neuron, effectively passing the baton of information. Among this bustling chemical crowd, one molecule stands out as the master of tranquility, a compound known as gamma-aminobutyric acid, or simply GABA. You can think of GABA as the brain's natural braking system. In a world full of excitatory signals telling your neurons to fire, to react, and to worry, GABA is the gentle hand that quiets the noise, inhibiting nerve transmission and preventing the brain from becoming overstimulated. When we experience chronic anxiety, it is often because this braking system is worn down, or the receptors meant to catch these calming molecules have become less sensitive, leaving the engine of the mind racing without a way to slow down. Working alongside this inhibitor is another celebrity of the chemical world, serotonin, which plays a dual role that is absolutely critical for the anxious mind. While often simplified as the happiness hormone, serotonin is actually a complex modulator of mood, acting like a thermostat that keeps our emotional responses within a comfortable range. What is particularly fascinating is the intimate relationship between serotonin and sleep. The very chemical that helps you feel calm and content during the day is chemically converted by the pineal gland into melatonin when darkness falls. This means that anxiety, which depletes serotonin reserves or disrupts its transmission, directly steals the raw materials your brain needs to manufacture the hormone that allows you to sleep, creating a cycle where worry fuels wakefulness and wakefulness fuels further worry. While serotonin manages the baseline, our mood, dopamine handles the sharp peaks of anticipation, playing a trickier role in anxiety than most realize. We typically associate dopamine with reward and pleasure, but functionally, it is the molecule of motivation and uncertainty. It is released not just when we get what we want, but when we are unsure if we will get it. In the context of anxiety, dopamine drives the compulsion to check things, to check the news, to check your phone, to check if the door is locked. It creates a state of high alert, keeping the mind scanning the horizon for potential threats or resolutions, turning the ambiguity of the future into a chemically demanding present. Completing this quartet of influence is norepinephrine, a chemical cousin to adrenaline that acts within the brain to mobilize the mind for action. It is the architect of alertness, sharpening focus and narrowing attention onto whatever the brain perceives as important. In moderate amounts, norepinephrine is what allows you to concentrate on a difficult task or wake up feeling refreshed. However, when anxiety commands the brain to release this chemical in surplus, that helpful focus morphs into hypervigilance. The sensation of a racing heart or a sudden sheen of sweat is the physical echo of norepinephrine flooding the system, preparing the body for a danger that often does not exist. These chemical tides are not static. They follow a rhythmic dance that mirrors the rotation of the Earth. A healthy brain sees a surge of cortisol and alertness chemicals in the morning to wake us, which slowly taper off as the day progresses, giving way to the restorative rise of adenosine and melatonin. Anxiety disrupts this circadian flow, often causing spikes of alertness chemicals late at night when the brain should be drifting into the low energy state of GABA dominance. Understanding these microscopic couriers offers us a profound insight. The feelings of panic or worry are not flaws of character, but fluctuations in a biological language. Yet, these chemicals do not float in a void. They require a physical infrastructure to travel, a vast network of biological wiring that connects the brain to every corner of the body. This brings us from the fluid world of chemistry to the solid architecture of the nervous system itself. At the center of this architecture lies a cable of incredible complexity, a biological superhighway known as the vagus nerve. Its name is derived from the Latin word for wanderer,
a fitting title for the longest of the cranial nerves, which meanders from the brainstem down through the neck, branching out to touch the heart, the lungs, and deep into the digestive tract. This nerve acts as the primary command channel of the parasympathetic nervous system, the body's natural relaxation response, effectively serving as the brake pedal that slows us down after a stressful event. Scientists speak of something called vagal tone, which is essentially a measurement of this nerve's fitness, much like muscle tone in the arms or legs. A higher vagal tone correlates with better emotional resilience, allowing a person to snap back to a state of calm more quickly after a shock, while low vagal tone is often linked to chronic anxiety and a heart that struggles to return to a resting rhythm. This connection explains why we feel anxiety physically in the gut, often described as a pit in the stomach or sudden nausea. The vagus nerve is transmitting the brain's distress signals directly to the enteric nervous system, halting digestion to save energy for survival. This redirection of energy creates a cascade of other physical symptoms that can feel alarming but are merely the body's attempt at protection. For instance, you may have noticed that your hands tremble or shake during moments of high anxiety. This is not a sign of weakness, but rather a side effect of adrenaline flooding the major muscle groups to prepare them for explosive action. The body deprioritizes fine motor control in favor of gross motor strength, leaving your fingers with an excess of potential energy that manifests as a tremor. Simultaneously, blood vessels in the extremities constrict, funneling warm oxygenated blood toward the biceps and thighs, which is why your hands and feet often turn icy cold when you are nervous. Even the phenomenon of sweaty palms has a distinct evolutionary logic rooted in this nervous system activation. While we typically sweat to cool down, the moisture released on the palms during stress is technically known as emotional sweating, thought to be an ancient biological adaptation to improve grip on rocky surfaces or tree branches during an escape. It is fascinating to consider how these ancient survival mechanisms manifest in our modern lives. If you have ever noticed a specific physical tell like this, perhaps cold fingers or a sudden heat, share your experience in the comments, as understanding these physical quirks helps us realize we are not broken, just biologically prepared. Beyond the active states of fight or flight, the vagus nerve also controls a third, often overlooked survival state known as the freeze response. Mediated by the dorsal branch of the vagus nerve, this is the most primitive defense mechanism, an evolutionary holdover from our reptilian ancestors who would play dead to avoid detection by a predator. In humans, this manifests as dissociation, a feeling of being stuck, or the sudden inability to speak during a stressful presentation, as the nervous system determines that movement is too dangerous and shuts down completely. Once these electrical signals travel through the vagal pathways, they trigger the release of powerful compounds, initiating the next phase of the anxiety response, the hormonal cascade. This biochemical chain reaction begins in a small region of the brain called the hypothalamus, which acts as the control tower for the entire operation. It sends a chemical signal to the pituitary gland, a pea-sized organ at the base of the brain, which in turn relays the message down to the adrenal glands perched atop the kidneys. This trio is known to scientists as the HPA axis, a highly efficient communication network that has evolved over millions of years to prioritize survival above all else. When this axis is activated, the adrenal glands begin their work, releasing a specific cocktail of chemicals, the most prominent of which is cortisol. While often simply labeled as the stress hormone, cortisol is actually a vital resource manager, tasked with mobilizing fuel for the body's engines. Its primary job in this state is to flood the bloodstream with glucose, tapping into the liver's energy stores to ensure your muscles have immediate access to high-grade sugar. This massive dump of biological fuel is intended to power a sprint to safety, which is why anxiety often manifests physically as a trembling restlessness or a jittery urge to move.
Your body is revving its engine, fully fueled and waiting for a physical release that, in modern situations like a meeting or a traffic jam, rarely comes.
This relationship between cortisol and energy also sheds light on a common phenomenon known as the cortisol awakening response. In a perfectly balanced system, cortisol levels naturally surge by about 50% in the first 30 minutes after waking, acting as a biological alarm clock to clear away sleep inertia. However, for those living with chronic anxiety, this baseline is already elevated, meaning the natural morning spike pushes the system into overdrive, causing one to wake up with a pounding heart or a sense of dread before the day has even begun. Working in tandem with cortisol is adrenaline, or epinephrine, which handles the immediate sensory adjustments required for danger. Adrenaline acts on the smooth muscles of the eyes, causing the pupils to dilate rapidly. This expansion allows more light to hit the retina, sharpening vision and creating a tunnel-like focus on potential threats, though it often leads to light sensitivity and blurred vision when there is no actual danger to focus on. Even more fascinating is how adrenaline alters human hearing. It tightens the tiny tensor tympani muscle within the ear, dampening the perception of low-frequency background noises and amplifying high-frequency sounds. This evolved to help ancient humans hear the snap of a twig or the hiss of a predator, but today it simply makes the hum of a refrigerator or the chatter of a crowd feel overwhelmingly loud and abrasive. As these resources are aggressively allocated to the senses and the muscles, the body makes a calculated decision to shut down non-essential maintenance projects, starting by diverting blood flow away from the digestive system. This sudden physiological evacuation is the precise biological mechanism behind that familiar sinking sensation of a knot forming in your stomach or the fluttering of butterflies before a significant event. It is not merely a poetic metaphor for nervousness, it is the tangible feeling of your digestive system pausing its work and the blood draining away to prioritize survival elsewhere. This profound connection between your stomach and your mood exists because the gut is actually far more than a simple fuel processing center. It is often referred to by neuroscientists as the second brain. Known technically as the enteric nervous system, this complex mesh of neurons lining your gastrointestinal tract is so sophisticated that it can operate independently of the brain in your head and the spinal cord. It contains between 100 and 500 million neurons, which is more than you would find in the entire spinal cord or the peripheral nervous system. While this second brain does not compose symphonies or solve complex equations, it is constantly communicating with the primary brain via the vagus nerve, a massive biological information superhighway that transmits signals in both directions. For a long time, scientists believed the brain did most of the talking, sending orders down to the gut, but we now know that 80 to 90% of the nerve fibers in the vagus nerve are actually sending information from the gut up to the brain. Perhaps the most startling revelation in this relationship concerns serotonin, the crucial neurotransmitter associated with feelings of well-being, mood regulation, and happiness. We often imagine serotonin as a chemical residing strictly within the cranial vault, yet approximately 95% of the body's serotonin is produced and stored not in the head, but in the gut. This means that the biological environment of your digestive tract has a direct chemical leverage over your emotional baseline. The implications here are profound because it suggests that anxiety is not always a top-down process starting with a worried thought, but can often be a bottom-up phenomenon starting with an imbalance in the belly. This naturally leads us to wonder about the fuel we put into this system. I would be very interested to hear your own observations on this. Do you notice specific foods that seem to calm your mind, or conversely, foods that make you feel jittery or uneasy? Please share your experiences or any patterns you have noticed in the comments below, as seeing how others navigate nutrition and mood can be wonderfully validating. This conversation continues deep into the microscopic world within us, known as the microbiome.
Your gut is home to trillions of bacteria, fungi, and viruses that form a bustling ecosystem unique to you, weighing roughly as much as the brain itself. Recent studies suggest that the composition of these microbes plays a pivotal role in anxiety regulation. When the ecosystem is diverse and healthy, it produces byproducts that reduce stress signaling. However, when that balance is disrupted, a state called dysbiosis, it can send inflammatory signals up the vagus nerve, triggering anxiety in the brain even when there is no external threat in the environment. Scientists are even exploring psychobiotics, specific strains of beneficial bacteria that might one day be used to treat anxiety, further cementing the reality that our mental health is deeply rooted in our biology. This intricate biological machinery, from the firing of amygdala neurons to the bacterial colonies in the gut, has evolved for millions of years to keep us safe. Yet our scientific understanding of this system is relatively new. For most of human history, the racing heart, the shallow breath, and the worried mind were viewed through a very different lens. To truly understand anxiety, we must look back at how our ancestors interpreted these intense sensations before they had the language of neuroscience to explain them. If we were to walk the sun-bleached marble streets of Athens 2,400 years ago, we would find Hippocrates, the father of medicine, puzzling over patients who seemed consumed by a shapeless, persistent fear. He did not diagnose them with anxiety disorders as we define them today, but rather looked to the elemental fluids of the body for an explanation. In the ancient world, it was believed that the human temperament was governed by 4 distinct humors, and when a person was plagued by excessive worry, trembling, or despondency, it was interpreted as a physical sign that the body held too much black bile. This condition was called melancholia, a word that literally translates to black bile, painting a vivid picture of worry not as a flaw of character, but as a physiological imbalance, as tangible and natural as a fever or a broken bone. While the physicians of antiquity looked to these internal fluids, the philosophers of Rome looked to the architecture of the mind itself. It is profoundly grounding to realize that the Stoics, including the emperor Marcus Aurelius and the playwright Seneca, developed what was essentially an ancient precursor to modern therapy. They taught that anxiety was not caused by the world around us, but by our opinions about that world. Seneca, writing by candlelight in the 1st century, penned a sentiment that still resonates in our modern frantic lives, famously noting that we suffer more often in imagination than in reality. This suggests that for thousands of years, humans have deeply understood that the anticipation of trouble is a far heavier burden to carry than the trouble itself. As history turned the pages toward the Renaissance and the Enlightenment, the understanding of this inner restlessness shifted once again. Medical thinkers began to view the body less as a vessel of liquid humors and more like a complex musical instrument strung with taut fibers. They began to speak of the nerves, a term derived from the Latin word for sinew or bowstring. Anxiety was often described during this era as a case of the vapors, a poetic yet medical idea suggesting that internal spirits were rising from the organs to cloud the brain, much like mist rising from a damp field at dawn. It was a gentle way of acknowledging that the clarity of the mind could be obscured by the body's internal weather. However, the texture of human worry changed profoundly with the arrival of the steam engine and the factory whistle. The Industrial Revolution did not just change how we worked, it fundamentally altered the baseline of human stress. For the first time in history, daily life was dictated not by the slow rhythms of the rising sun or the changing seasons, but by the precise, unforgiving ticking of the mechanical clock. This era gave birth to the concept of neurasthenia, or exhausted nerves, a diagnosis popularized in the 19th century to explain why modern people felt so perpetually on edge. It was believed that the rapid pace of civilization was depleting the body's electrical energy reserves, a theory that feels remarkably ahead of its time given our current conversations about burnout and fatigue. This modernization of society paved the way for a deeper, more existential view of worry that emerged as the world became more complex. Philosophers like Søren Kierkegaard began to strip away the medical explanations to look at the human soul itself. He proposed the fascinating idea that anxiety was not merely a symptom of illness, but a fundamental feature of being alive. He famously described anxiety as the dizziness of freedom, likening it to the overwhelming sensation of standing on a cliff edge, realizing that you are free to jump or stay put, and that the sheer weight of infinite possibility is what makes the heart race. It is this vertigo that ultimately proves we are distinct from the rest of the animal kingdom. Kierkegaard posited that if we were merely beasts driven entirely by instinct, we would move through the world without this specific form of dread, simply acting on impulse without the heavy burden of weighing alternatives. In this sense, anxiety is not merely a symptom to be eliminated, but a testament to our potential, a signal that we are conscious, awake, and capable of shaping our own destiny. He even went so far as to suggest that whoever has learned to be anxious in the right way has learned the ultimate act of being human, for they understand the vastness of their own possibilities. Moving into the 20th century, the philosopher Martin Heidegger took this concept deeper, drawing a sharp and famous distinction between fear and what he termed angst. This is a critical nuance that helps us understand the texture of our own emotions. For Heidegger, fear is always directed at something specific within the world. You are afraid of a growling dog, a steep drop, or a sudden fire. The threat is tangible. You can point a finger at it and say, "That is why I am afraid."
We suddenly feel like strangers in our own lives. While this sensation can be deeply unsettling, Heidegger argued it serves a vital function. It jolts us out of our autopilot mode. Most of the time, we drift along doing what they say we should do, following societal norms, absorbed in idle chatter and distracting ourselves with trivia. Anxiety interrupts this slumber. It strips away the comfort of the crowd and forces us to confront our own individual existence, presenting us with a clear, albeit intimidating, invitation to live authentically. The French existentialist Jean-Paul Sartre echoed this sentiment, famously declaring that we are condemned to be free. This dramatic phrasing highlights that we cannot escape the responsibility of making choices. Every moment requires a decision, even if that decision is to do nothing. And this constant requirement to write the story of our lives without a pre-existing script creates a background hum of tension. We realize that there are no guardrails, and we alone are responsible for our values and actions. This philosophical framework provides the foundation for understanding why anxiety feels so pervasive. But as we moved into the modern era, our understanding evolved from the spiritual to the scientific. We began to realize that while some anxiety is a natural response to the freedom of existence, other forms are distinct, repetitive patterns that affect the body and mind in specific ways. This realization marked the transition from viewing anxiety solely as a philosophical condition to understanding it as a clinical spectrum. We started to map the geography of these feelings, categorizing them not just by their existential weight, but by their symptoms and triggers, leading us to identify the specific types of anxiety that science recognizes today. The most pervasive landscape on this map is what clinicians call generalized anxiety disorder, or GAD. Unlike the sudden crashing waves of panic that we might discuss later, GAD is akin to a rising tide that never quite recedes. It is characterized not by a single terrifying event, but by a constant, low-frequency hum of apprehension running in the background of daily life. Imagine a radio left on in a distant room, playing static at a volume just low enough to be ignored for moments, but loud enough to be exhausting over the course of a day. This is the physiological reality for millions, a baseline state of arousal that remains elevated, keeping the nervous system in a semi-permanent posture of defense against threats that may never actually materialize. This persistent vigilance fuels a cognitive pattern known as the worry chain. It acts like a mental domino effect, where a single thought about a minor inconvenience, perhaps a strange noise in the car engine, does not stay contained. Instead, it links instantly to a larger fear about a breakdown, which hops to the cost of repairs, then to financial instability, and finally lands on a catastrophic vision of the future. This mental hopping happens in seconds, transforming a mundane trigger into a profound sense of impending doom. It is a creative, if exhausting, misuse of the imagination, where the brain works overtime to connect dots that don't necessarily belong together. At the core of this experience is a trait psychologists call the intolerance of uncertainty. For the anxious mind, the unknown is not a space of possibility, but a vacuum that must be filled with predictions, usually of the worst-case variety. It's a subconscious attempt to gain control. The brain effectively decides that it is safer to be worried and prepared than to be relaxed and caught off guard. This drive is so potent that studies suggest those with high levels of anxiety often prefer a guaranteed negative outcome over an uncertain one, simply because the ambiguity of waiting is more painful than the bad news itself. This internal struggle is surprisingly common. Research indicates that in any given year, roughly 3 to 6% of the adult population is navigating this persistent landscape, making it one of the most frequent mental health challenges globally. The data also reveals a gender disparity, with women being nearly twice as likely to be diagnosed as men, though this may reflect differences in how willing we are to report these feelings as much as biology. It represents a silent multitude, a vast number of people quietly managing the internal static while appearing perfectly calm on the surface. However, while generalized anxiety is broad and free-floating, attaching itself to everything from health to work, there is another distinct territory on our map where the anxiety becomes laser-focused on a specific target: the eyes of others. As we shift our focus from the general to the interpersonal, we enter the realm where the primary fear is not of a dangerous world, but of judgment within it. This judgment forms the cornerstone of what we call social anxiety, a deeply misunderstood mechanism that is less about shyness and more about prehistoric survival. To understand why an awkward silence at a dinner party can feel physically life-threatening, we have to look at the harsh realities of our ancestors. For early humans, social rejection was not merely an emotional bruise, it was effectively a death sentence. Being cast out of the tribe meant facing the freezing night, starvation, and predators entirely alone.
Consequently, the human brain evolved to register social rejection in the same neural regions that process physical pain. When you feel the sharp sting of embarrassment, your body is reacting as if you have been physically wounded, alerting you to the immediate danger of being isolated from the group's protection. This ancient survival drive creates a fascinating cognitive distortion known in psychology as the spotlight effect. This is the convincing, often overwhelming sensation that you are the lead character in a movie that everyone else is watching, causing you to drastically overestimate how much others notice your appearance or behavior. In famous studies where participants were asked to wear embarrassing t-shirts into a crowded room, they predicted that at least half the room would notice. In reality, less than a quarter did. Most people are walking around in their own spotlight, consumed by their own internal monologue, barely registering the stain on your shirt or the way you stumbled over a word. It is a liberating realization that most people are far too busy worrying about how they are perceived to judge how you are perceived. Tell us in the comments if you have ever felt that burning sensation of the spotlight, only to realize later that no one had actually noticed what you were worried about. It is also crucial to distinguish between this fear and simple introversion, as the two are often conflated. Introversion is a temperamental preference for low stimulation environments. An introvert recharges their energy in solitude, but may feel perfectly confident and calm during social interactions. Social anxiety, conversely, is rooted in fear. A socially anxious person might desperately crave connection and the energy of a crowd, yet feels held back by the terrifying possibility of scrutiny. The introvert chooses to stay home to rest. The anxious person stays home to stay safe. When this safety feels compromised, the body triggers a unique and somewhat paradoxical signal: blushing. This uncontrollable rush of blood to the face and neck is arguably the most peculiar of all human expressions because it's exclusively human. Charles Darwin famously struggled to explain it, noting the irony that it draws attention to us exactly when we wish to be invisible. Modern evolutionary psychology suggests that blushing serves as a trusted non-verbal apology, a signal of submission that instantly tells the group, "I realize I have violated a social norm and I care about your opinion." It is a biological white flag intended to diffuse aggression and garner forgiveness. While social fears keep us looking over our shoulders at other people, there are other anxieties that look elsewhere, down from great heights, into the dark corners where shadows move, or toward the erratic motion of wings. As we leave the complex world of human judgment, we find that the brain's alarm system can attach itself to very specific, tangible triggers in the environment. This creates a fundamental distinction between a rational fear, which keeps us safe, and a clinical phobia, which actively interferes with our ability to live freely. While standard fear is a helpful burst of adrenaline that advises us to step back from a growling dog, a phobia is a misfiring of that same protective circuitry, launching a full-scale evacuation protocol in response to a harmless stimulus. This reaction is often rooted deep in our genetic history, acting as a ghostly echo of the dangers that threatened our ancestors on the savannah. Consider the pervasive fear of heights, known as acrophobia. It's not merely a dislike of high places, it's a physiological rejection of the vertical drop. Evolutionarily, this makes perfect sense. For early humans without safety rails or harnesses, a fall was a terminal event. Consequently, we have developed an innate visual cliff response. Studies involving very young children show that even before they have learned the concept of gravity or injury, they will hesitate and refuse to crawl over a clear pane of glass that reveals a drop beneath them. The brain is hardwired to prioritize solid ground, and in those with acrophobia, this wiring is simply dialed up to maximum sensitivity, inducing vertigo to force the body to lower its center of gravity and freeze. We see a similar evolutionary imprint in ophidiophobia, the fear of snakes. It's one of the most common specific phobias worldwide, even in countries where snakes are rare or non-venomous. Researchers have found that the human brain is exceptionally fast at detecting the winding, sinuous patterns typical of a snake, spotting them in a cluttered image much faster than it spots flowers or frogs. This is likely because, for millions of years, the ability to spot a camouflaged predator in the grass was a primary determinant of survival. We are the descendants of the humans who noticed the snake. This brings us to a fascinating concept in psychology known as preparedness theory. It poses the question, why are we terrified of spiders and darkness, but not of cars or electrical outlets? Statistically, a car is thousands of times more lethal than a house spider. However, automobiles and electricity are recent inventions, existing for only a blink of an eye in evolutionary time. Our brains have not yet had the thousands of years required to develop a genetic template for fearing a wall socket. We are prepared by evolution to fear ancient threats, meaning we learn to fear a spider after one bad surprise, whereas we might need repeated warnings to learn to respect the danger of a high-voltage wire. Sometimes the brain's pattern recognition software malfunctions in curious ways, leading to phobias that seem illogical on the surface. Trypophobia, the aversion to clustered holes or repetitive bumps, is a prime example. While it may seem strange to fear a lotus seed pod or the bubbles in a sponge, evolutionary biologists suggest this is a misplaced survival instinct. Many poisonous animals, like the blue-ringed octopus, and various infectious skin diseases present with similar clustered patterns. The brain, in an overzealous attempt to avoid contagion or poison, interprets these harmless geometric shapes as a biological threat, triggering a sensation of disgust and skin-crawling anxiety rather than pure terror. Of course, not all fears are inherited from the Stone Age. Many are written into our neural pathways through experience, a process known as conditioning.
The famous, albeit melancholic, psychology experiments of the early 20th century demonstrated this clearly. By pairing a neutral object, like a white rabbit, with a startling loud noise, researchers found they could train a child to fear the rabbit. The brain links the innocent object with the startling sensation, creating a new, learned trigger. This suggests that for many adults, a sudden phobia of dogs or water may be the long-held shadow of a forgotten afternoon from childhood where specific events startled the nervous system. Once this association is locked in, the object itself becomes a switch that, when flipped, bypasses logic and activates the body's most intense emergency state, leading us away from simple worry and toward the overwhelming physical reality of panic. Once that physical reality takes hold, a fascinating and complex phenomenon occurs known as the physiological feedback loop, or quite simply, the fear of fear itself. It begins with a single, often subtle sensation, perhaps a slight flutter in the chest, a feeling of warmth, or a momentary dizziness. Under normal circumstances, the brain would filter this out as irrelevant background noise, but in a sensitized state, the amygdala highlights this sensation as a priority threat. The conscious mind notices the flutter and immediately interprets it as a sign of imminent health collapse or loss of control. This catastrophic interpretation acts as a secondary trigger, causing the adrenal glands to release a fresh wave of epinephrine. Consequently, the heart beats even faster, which the brain then perceives as confirmation that something is indeed terribly wrong. It becomes a closed circuit of escalation, where the body's response to the fear becomes the very source of the fear, spinning tighter and faster until the physical sensations feel all-encompassing. Central to this mechanics of respiration is the mechanics of respiration. When the alarm sounds, the body's ancient instinct is to intake more oxygen to fuel the large muscles for a potential fight or a flight. You might begin to breathe rapidly and shallowly, a process called hyperventilation. While it often feels subjectively like you are suffocating or running out of air, the biological reality is actually the opposite. You are breathing too much. This rapid exchange expels carbon dioxide from the lungs faster than the cells can produce it, leading to a sudden drop in CO2 levels in the blood. This specific chemical shift, known as respiratory alkalosis, changes the pH balance of the blood just enough to cause the protein in the blood to hold on to oxygen more tightly, and it causes blood vessels in the brain to constrict slightly. This is precisely what causes the distinct feeling of lightheadedness, the tunnel vision, and the strange tingling sensation in the extremities, often felt in the fingertips or lips. It creates a paradox where the desperate hunger for air is actually a symptom of having low carbon dioxide, yet the instinct is to breathe even harder, feeding the cycle further. Despite the intensity of this chemical storm, it is comforting to know that a panic attack is biologically self-limiting. The body simply cannot sustain that level of acute arousal indefinitely because it has a limited supply of the necessary neurotransmitters and energy. While the experience distorts time, making minutes feel like hours, clinical observation shows that the adrenaline surge typically peaks within 10 minutes and rarely lasts longer than half an hour. The parasympathetic nervous system, the body's natural brake pedal, eventually and inevitably kicks in to metabolize the stress hormones and bring the heart rate down. In this way, a panic attack is best understood as a false alarm in a highly sensitive, state-of-the-art security system. The bells are ringing, the gates are locking, and the sprinklers are flooding the room, which feels incredibly destructive, but there is no actual fire. The machinery is working perfectly, it has just been triggered at the wrong time. This brings us to a curious question for you. Have you ever experienced a physical sensation that turned out to be a false alarm, and how did your body react once you realized you were safe? Tell us in the comments what that moment of relief felt like. Once the sirens fade and the chemical tide recedes, the experience is not merely discarded by the mind. The brain, ever the diligent archivist, attempts to learn from the event to ensure survival in the future. The hippocampus, the region responsible for contextual memory, begins to encode the details of the environment where the panic occurred, taking a snapshot of the location to bind the memory of the place to the memory of the feeling. Under normal circumstances, this binding is a masterpiece of biological organization, allowing you to distinguish between a threat in a dangerous alley and the similar shadow in the safety of your own bedroom. However, this delicate machinery is highly sensitive to the chemical surges that accompany chronic anxiety. One of the most profound physiological changes caused by long-term stress involves the hormone cortisol, which, while essential for the fight or flight response, becomes toxic in excess. The hippocampus is covered in receptors for cortisol, making it uniquely vulnerable to being overwhelmed. Studies using neuroimaging have revealed a startling correlation. In individuals suffering from severe, untreated anxiety or post-traumatic stress, the hippocampus can actually physically shrink in volume. This atrophy impairs the brain's ability to discriminate between safe and unsafe environments, leading to a generalization of fear, where the brain begins to flag harmless situations as dangerous simply because they bear a faint resemblance to a past memory. This helps explain why anxiety can feel so pervasive. The neurological librarian responsible for filing your memories into the correct safe or unsafe categories has become overworked and understaffed. This structural change also highlights the fascinating distinction between explicit and implicit memory. Explicit memory is your conscious recollection of an event, the who, what, and where, which relies heavily on the hippocampus. Implicit memory, conversely, is the unconscious, emotional, and physical retention of an experience, primarily stored in the amygdala. During a moment of extreme panic, the flood of stress hormones can disable the hippocampus, preventing it from forming a clear narrative memory of the event, while the amygdala continues to record the emotional intensity and physical sensations perfectly. This creates a fragmented experience where a person may feel an overwhelming surge of dread or a racing heart without any conscious memory of why, a phenomenon often described as the body remembering what the mind has forgotten. This separation of feeling from fact is frequently triggered by our most primal sense, smell. Unlike sight or sound, which must pass through the thalamus, the brain's central relay station, before being processed, olfactory signals have a VIP pass directly to the limbic system. The olfactory bulb connects straight to the amygdala and hippocampus, meaning a specific scent can trigger an immediate visceral anxiety response milliseconds before your conscious brain realizes what you were smelling. A whiff of a specific cologne, the scent of antiseptic, or the smell of rain can unlock a cascade of neurochemical panic without your permission, bypassing logic entirely. These fragmented sensory-based memories are waiting to be processed and integrated, a task the brain attempts to perform most intensively during our resting hours. It is in the quiet of the night that the mind tries to sort these emotional files, which naturally leads us to the complex bidirectional relationship between our anxious thoughts and the restorative power of sleep. This cycle is often described by neuroscientists as a bidirectional highway, meaning traffic flows heavily in both directions. Anxiety disrupts sleep, and sleep disruption in turn fuels anxiety. It is a feedback loop that many find themselves trapped within, yet understanding the biology behind it can be strangely comforting, as it reveals that these feelings are not a failure of character, but a physiological mechanism. When we are well rested, the prefrontal cortex, the logical, reasoning part of the brain, acts as a calm parent to the amygdala, the brain's emotional center. It inhibits the amygdala's reactivity, keeping our fears in check and our worries proportionate to reality. However, studies utilizing brain imaging have shown that after just one night of sleep deprivation, this connection is severed. The logical brakes are removed, and the amygdala becomes up to 60% more reactive to negative stimuli. This is why a problem that seemed manageable yesterday evening feels catastrophic after a restless night. The brain has literally lost its ability to regulate emotional volume. This leads to a phenomenon often referred to as being tired but wired, a state of physiological hyperarousal that is one of the most common complaints among those suffering from stress-induced insomnia. In this state, the body is physically exhausted, heavy with the weight of adenosine, the chemical that signals fatigue, yet the mind remains sharp, vigilant, and racing. This occurs because the sympathetic nervous system remains stuck in the on position, flooding the bloodstream with cortisol and adrenaline at the precise moment the body needs to wind down. It is a biological mismatch where the ancient survival mechanism of staying alert for predators clashes with the modern need for rest. Speaking of that transition to rest, we all have unique methods for trying to coax our nervous systems back to safety. I would love to hear what works for you personally.
Please share your favorite way to wind down before bed in the comments below. Whether it's a specific tea, a warm bath, or perhaps a particular soundscape, as your routine might be the perfect discovery for someone else reading along. Even when we do manage to drift toward the edge of sleep, anxiety has one more physical trick that startles many: the hypnic jerk. This is that sudden, involuntary muscle spasm that feels like you are falling off a curb just as you are losing consciousness. While these myoclonic twitches are harmless, they are significantly more common during periods of high stress or anxiety. One prevailing evolutionary theory suggests that as your muscles relax too quickly, a vigilant, anxious brain misinterprets this relaxation as a loss of balance, essentially thinking you are falling out of a tree, and sends a rapid electrical signal to the muscles to snap you back to safety. It's a false alarm from a protective brain that is trying a little too hard to keep you safe. Once we bypass these hurdles and achieve deep, slow wave sleep, the brain begins one of its critical anti-anxiety functions, the physical washing of the mind. It was only recently discovered that during deep sleep, the brain's waste clearance system, known as the glymphatic system, roars to life. The cells in the brain actually shrink by up to 60%, creating channels that allow cerebral spinal fluid to wash through the tissue, flushing out metabolic waste products and toxins that accumulate during waking hours. This nightly brain wash is essential for resetting our emotional baseline. Without enough deep sleep to complete this cleaning cycle, the brain remains cluttered with biological debris, leaving us chemically prone to irritability and anxious thoughts the next day. However, knowing how important sleep is can sometimes become the source of anxiety itself, a condition researchers now call orthosomnia. This is the perfectionistic quest for ideal sleep, often driven by sleep trackers and smartwatches. When we obsess over our sleep data or watch the clock ticking away the minutes of lost rest, we inadvertently engage in sleep effort. Sleep is one of the few things in life that becomes more elusive the harder we try to grasp it. This performance anxiety turns the bedroom into a battleground rather than a sanctuary, creating a paradoxical insomnia where the fear of not sleeping becomes the very cause of the sleeplessness. To break this, we must learn to let go of the effort, understanding that rest comes when we stop hunting for it. And when we finally do surrender to that tide, we drift beyond the deep, dark waters of slow wave sleep and enter an entirely different realm of consciousness, one where our anxieties are not just washed away, but actively processed in vivid hallucinatory detail. This is the domain of rapid eye movement, or REM sleep, a state that neuroscientists have poetically described as overnight therapy. It is during this phase that your brain performs a remarkable chemical magic trick. While your eyes dart back and forth behind closed lids, scanning internal horizons, the brain completely shuts off the production of noradrenaline, a stress molecule intimately tied to anxiety. For the only time in the 24-hour cycle, your emotional centers are reactivated, but your stress chemistry is totally absent. This creates a safe biological environment where the mind can reprocess upsetting memories or worries, essentially digesting them in a calm state so that when you wake, they feel less sharp and more manageable. This soothing biological mechanism is central to the sleep to forget, sleep to remember hypothesis proposed by sleep researchers. The theory suggests that we sleep to forget the visceral, painful emotional charge of a difficult experience, but we sleep to remember the useful informational lesson. It's the difference between remembering that a stove is hot versus reliving the searing pain of the burn every time you look at a kitchen. Without this nightly emotional stripping, our anxiety would compound day after day, leaving us in a state of chronic hyperarousal, unable to separate past trauma from present safety. However, sometimes the processing requires a more active dress rehearsal, which manifests in the universal language of anxiety dreams. It's a fascinating fact that across disparate cultures and continents, the most common themes of these dreams are remarkably similar, suggesting a deep evolutionary origin. Being chased, for instance, is widely considered a remnant of ancient threat simulation theory, where the brain practiced escaping predators while the body was safely paralyzed in bed. Then there's the classic nightmare of showing up for a final exam completely unprepared, or realizing you are naked in a crowded room. These are not random firings of a tired mind, but rather the brain's way of highlighting deep-seated feelings of vulnerability, social judgment, or competence, flagging areas where we feel exposed in our waking lives. If you've ever found yourself running from an unseen force or sitting in a classroom you don't recognize in your sleep, I would love to hear about it. Share your most common recurring dream theme in the comments below, as it is often comforting to see how many of us share the exact same nocturnal scripts. For some, the solution to these nocturnal anxieties lies in the skill of lucid dreaming.
This phenomenon occurs when the dreamer becomes fully aware they are dreaming while still asleep, a state that signals a shift in brain activity. Studies utilize EEG scans to show that during a lucid dream, the lateral prefrontal cortex, the logical, decision-making part of the brain that is usually dormant during sleep, wakes up. This unique hybrid state allows people to actively turn around and face the monster chasing them, often causing the threat to dissolve instantly. It transforms the nightmare from a helpless scenario into a controlled environment for emotional resolution, proving that even in sleep, agency is a powerful antidote to anxiety. Yet eventually, the dream state ends and we must open our eyes to a world that looks very different from the ancient savannas our biological systems were designed to navigate. While our internal biology is perfectly evolved to process the acute stress of a predator or a storm, it is far less equipped to handle the ceaseless, low-level hum of modern existence. We transition from the internal safety of sleep to the external barrage of the waking world, where the triggers are no longer lions or bears, but the artificial glow of screens and the relentless ping of digital demands. This creates a cognitive environment that researchers have termed continuous partial attention. Unlike multitasking, where we attempt to perform two distinct actions simultaneously, continuous partial attention is a state of constant, low-grade alertness. It is the mental equivalent of keeping a door slightly ajar, forever scanning the periphery for the next incoming signal or opportunity. This state keeps the body in shallow arousal, preventing us from ever sinking into the restorative depths of deep thought or true relaxation. It explains why you might feel physically exhausted after a day of merely sitting at a desk. Your brain has been running a marathon of micro-decisions and rapid focus switching, burning through glucose and energy reserves as it tries to filter the signal from the noise. The noise, however, is not always metaphorical. One of the most pervasive and overlooked sources of modern anxiety is invisible to the eye, but heavy on the nervous system: environmental noise pollution. Studies have consistently shown that individuals living near airports, railways, or busy urban roads possess higher baseline levels of cortisol, the stress hormone. This fascinating and somewhat troubling reality is that this physiological response occurs even if the person claims they have gotten used to the sound. Your conscious mind might successfully tune out the hum of the refrigerator, the whir of a computer fan, or the distant roar of traffic, but your autonomic nervous system does not. It continues to process these low-frequency vibrations and irregular sounds as potential threats, keeping the fight or flight mechanism simmering on a low heat day and night, denying the body the total silence it craves for recovery. This biological tax is compounded by the sheer volume of choices we're forced to make. In our ancestral past, a human might decide which path to track or which fruit to gather. Today, a visit to a standard grocery store presents us with 40 varieties of toothpaste and entire aisles dedicated to slightly different versions of the same cereal. Psychologists refer to this as the paradox of choice. While we logically assume that having more options offers more freedom and happiness, it actually generates a specific type of anxiety known as decision fatigue. Every small choice you make, what to wear, which route to drive, which email to archive, chips away at your limited supply of mental endurance. By the time evening arrives, the simple question of what should we have for dinner can feel surprisingly overwhelming because your brain's decision-making center is simply tapped out. Tell us in the comments if you've ever felt that specific paralysis when trying to pick a movie or a meal. It's a very common sign of a brain that has hit its daily limit of executive function. This fatigue is deeply exacerbated by the always-on culture that has systematically eroded the natural pauses in our lives. There was a time when waiting for a bus, standing in line at the bank, or waiting for a kettle to boil were moments of necessary boredom. These empty pauses allowed the brain's default mode network to activate, a neurological system essential for memory consolidation, self-reflection, and creativity. Now, those gaps are instantly filled by the reflex to check a feed or answer a message. We have effectively eliminated the downtime required for our nervous systems to reset, replacing golden silence with a steady, colorful stream of data. This brings us to the most potent delivery system for this sensory overload, a tool that has fundamentally rewired how we perceive the world and ourselves. This pocket-sized portal relies on a powerful psychological concept known as variable reward schedules, the exact same mechanism that makes slot machines so difficult to walk away from. When you pull down to refresh a social media feed, you're effectively pulling the lever of a casino machine, waiting with bated breath to see if you'll be rewarded with a notification, a like, or a breaking news story, or if you'll receive nothing at all. It's the unpredictability of the reward itself, rather than the content itself, that causes the brain to release a spike of dopamine.
This keeps the nervous system in a state of perpetual low-grade anticipation, never allowing it to fully rest because the next pull of the lever might deliver something important. This chemical loop feeds directly into the phenomenon we know as FOMO, or the fear of missing out. While often dismissed as modern slang, this anxiety is deeply rooted in our evolutionary history. For our ancestors, being unaware of the tribe's movements or losing status within the group could mean a literal death sentence. Therefore, our brains are hardwired to scan for social standing. In the digital age, this survival instinct creates a constant background hum of anxiety as we compare our internal, messy, and complex realities with the carefully curated, polished highlight reels of strangers. This creates a psychological discrepancy that the anxious mind interprets as a threat to its social survival, triggering feelings of inadequacy that are entirely manufactured by the platform's design. Beyond the anxiety of comparison, we encounter the phenomenon of doom scrolling. This compulsive need to consume negative news is actually a misfired survival instinct. Your brain is attempting to scan the environment for threats to keep you safe, believing that if it gathers enough information about a crisis, it can protect you. However, because the digital stream of bad news is infinite, the signal that you are safe never arrives. Consequently, the body remains locked in a sympathetic state of fight or flight, shallow breathing and tense muscles persisting as you scroll, waiting for a resolution that the screen cannot provide. The integration of this technology into our biological stress response is now so profound that it has given rise to a condition called phantom vibration syndrome.
This is a tactile hallucination where an individual physically feels their phone buzz in their pocket or hears it ping even when the device is silent, turned off, or in another room. Research suggests that the brain becomes so hypervigilant for connection that it begins to misinterpret simple sensory inputs like the friction of clothing or a muscle twitch as a digital alert. I am curious if your nervous system has adapted this way, so do tell us in the comments if you have ever felt that ghostly buzz when your phone wasn't even there. It is a stark reminder that what we consume with our eyes reshapes our biology. Yet it is not the only form of consumption that dictates our inner peace. Just as digital inputs can inflame the mind, the physical fuel we choose can either soothe our nerves or set them on fire, leading us to the profound connection between our diet and our mental state. Consider the morning ritual that defines modern wakefulness, the cup of coffee. While culturally beloved, caffeine acts as a potent chemical mimic within the nervous system. It functions primarily by blocking adenosine receptors, the chemical signals that tell your brain it is tired. But for the anxious mind, this artificial alertness comes at a steep price. Caffeine stimulates the adrenal glands to release adrenaline, essentially tricking the body into a fight or flight response even when no danger is present. Heart rate accelerates, palms sweat, and thoughts begin to race, creating a sensation that is physiologically indistinguishable from a panic attack. The duration of this effect is often underestimated, leading to what scientists call the caffeine cycle of anxiety. The half-life of caffeine is roughly 5 to 6 hours, meaning that if you consume a strong coffee at 4 in the afternoon, half of that stimulant is still active in your bloodstream at 10 at night, interfering with deep sleep and setting the stage for higher anxiety the following day. I'm curious, and I'd love to read your thoughts in the comments. Have you ever noticed a specific time of day where caffeine turns from helpful to jittery for you? Or have you had to cut it out completely to protect your peace of mind? Beyond stimulants, the stability of our mood is tethered to the stability of our blood sugar. When we consume high glycemic foods, sugary snacks, or refined carbohydrates, glucose levels spike rapidly, only to crash hours later. This sudden drop, known as reactive hypoglycemia, triggers a desperate signal from the brain to release stress hormones like cortisol and adrenaline to liberate stored energy. The physical symptoms of this crash, trembling, irritability, lightheadedness, and a pounding heart, are so similar to acute anxiety that many people suffer through panic episodes that are actually biological cries for sustained fuel. Conversely, certain nutrients act as a balm for these frayed nerves. Magnesium, often referred to as the relaxation mineral, plays a critical role in regulating the hypothalamic pituitary adrenal axis, the body's central stress response system. Despite its importance, modern agricultural practices have depleted magnesium from the soil, leaving many of us deficient and chemically prone to tension. Restoring levels through dark leafy greens, nuts, or seeds can physically relax tense muscles and calm a hyperactive mind. Similarly, B vitamins, particularly B6 and B12, are essential for synthesizing the neurotransmitters serotonin and dopamine. Without these chemical precursors, the brain lacks the raw materials necessary to construct feelings of well-being and stability. Even the most basic element of life, water, dictates our emotional resilience.
Even mild dehydration, a loss of just 1 or 2% of body water, has been shown to increase cortisol levels and impair cognitive function. The brain, sensing a lack of fluid, enters a low-level survival mode, manifesting as brain fog and edginess that feels like emotional distress but is simply physiological thirst. Correcting these biochemical imbalances creates a solid foundation. Yet, a nourished body is meant to do more than sit still. It is designed to move, leading us to the powerful interplay between physical exertion and mental release. One of the most intriguing paradoxes in the science of anxiety is that the physical sensations of vigorous exercise are nearly identical to the symptoms of a panic attack. When you exert yourself, your heart races, your breath shortens, you may sweat, and your body temperature rises.
However, when we induce these sensations voluntarily through movement, we are engaging in a biological form of exposure therapy. By intentionally raising the heart rate in a controlled environment, the brain learns a crucial distinction: that a fast-beating heart does not always signal immediate danger. Over time, this trains the amygdala, the brain's threat detection center, to become less reactive to physical arousal, effectively teaching the body that it is safe even when it is active and alert. Deep within the neural architecture, aerobic exercise triggers the release of a remarkable protein known as brain-derived neurotrophic factor, or BDNF. You might think of BDNF as a premium fertilizer for the brain. Chronic anxiety and stress can actually cause neurons in the hippocampus to wither, shrinking the very part of the brain responsible for memory and emotional regulation. BDNF counteracts this decay. It encourages the growth of new neurons and strengthens the synaptic connections between them, physically rebuilding the brain's infrastructure to be more resilient and flexible in the face of future stressors. For decades, popular science attributed the blissful floating feeling following a run or a swim solely to endorphins, the body's natural painkillers. While endorphins do play a role, more recent research highlights the endocannabinoid system as a primary driver of this calm. Exercise increases the circulating levels of anandamide, a molecule named after the Sanskrit word for bliss. Unlike endorphins, which are large molecules that struggle to cross the blood-brain barrier, anandamide passes through easily, binding to receptors in the brain to reduce anxiety and induce a profound sense of well-being. There is also a soothing medicine found in the simple geometry of movement. Activities like walking, swimming, or cycling involve bilateral stimulation, meaning they require the rhythmic alternating use of the left and right sides of the body. This repetitive left-right motion has a direct sedating effect on the nervous system, helping to process and metabolize stuck emotional energy. It's why a long walk often untangles a messy mind better than sitting still ever could. I'm curious to know, is there a specific physical activity, perhaps a rhythmic one like walking or swimming, that you find consistently clears your mind? Let me know in the comments. We must also consider that our muscles are not merely mechanical pulleys for lifting and moving, they are endocrine organs. When skeletal muscles contract, they secrete myokines, chemical messengers that travel to the brain and act as powerful anti-inflammatories for the mood. Furthermore, well-conditioned muscles help purge the blood of a substance called kynurenine, which creates stress-induced inflammation in the brain. Essentially, your muscles act as a filtration system, physically working the stress out of your bloodstream. This biological drive to move often compels us to leave our enclosed spaces, leading us towards the one environment that our nervous system recognizes as its true home. That true home is, of course, the natural world, a concept scientifically formalized as the biophilia hypothesis. This theory suggests that humans possess an innate tendency to seek connections with nature and other forms of life, primarily because we spent 99% of our evolutionary history adapting to the wilderness, not to concrete cities. When you step into a park or walk along a riverbank, your brain recognizes the environment it was designed to navigate, leading to an almost instant reduction in the constant low-level vigilance required to process the sharp angles, loud noises, and fast movements of modern urban life. This relaxation response is partially triggered by the visual geometry of nature itself, specifically through patterns known as fractals. Fractals are complex, self-repeating patterns that look similar at any scale, found abundantly in the branching of trees, the veins of leaves, the scattering of clouds, and the jagged lines of a coastline. Neuroscientific research indicates that the human visual cortex is genetically optimized to process these fractal patterns with minimal effort, a phenomenon called fractal fluency.
When your eyes rest on the chaotic yet organized structure of a fern or the texture of ocean waves, your brain's processing load decreases significantly, shifting from a state of focused strain to what psychologists call soft fascination. Studies have shown that simply looking at fractal patterns in nature can reduce physiological stress markers by as much as 60%, suggesting that beauty is not just an aesthetic appreciation, but a biological necessity for nervous system regulation.
This interaction goes beyond what we see, extending into the very air we breathe, a concept perfected by the Japanese practice of Shinrin-yoku, or forest bathing. While the poetic idea of bathing in the forest atmosphere is beautiful, the science behind it is rooted in chemistry. Trees and plants emit volatile organic compounds called phytocides to protect themselves from rotting and insects. When humans inhale these airborne wood essential oils, our bodies respond by increasing the activity of natural killer cells, a type of white blood cell that boosts immune function and rapidly degrades stress hormones. A mere 20-minute walk in a forest can lower blood pressure and cortisol levels far more effectively than a walk of the same duration in a city center, proving that the forest is actively medicating us through the air. Considering how deeply these environments affect our internal state, I am curious to know where your mind drifts when you need peace. Do you find yourself longing for the deep silence of a dense forest, the rhythmic crashing of the ocean, or the vast open perspective of a mountain peak? Share your favorite natural sanctuary in the comments below, as different landscapes often soothe different types of anxiety. While the landscape grounds us, the sky above plays an equally critical role in regulating our anxious minds through the mechanism of light. The human body operates on a circadian rhythm heavily influenced by the intensity of light hitting the retina, which directly signals the brain to produce serotonin, the mood-stabilizing neurotransmitter. In the darker months, the lack of sufficient lux, or light intensity, can lead to seasonal affective disorder, where the brain essentially enters a state of hibernation, conserving energy and increasing anxiety and lethargy. Modern indoor lighting often provides less than 500 lux, whereas a bright sunny day offers upward of 100,000 lux, a disparity that explains why simply stepping outside can feel like flipping a switch on your mood. As we stand in that light, surrounded by the geometry of nature, we engage in the most fundamental exchange with our environment, a rhythm that dictates life itself and serves as the master switch for our nervous system, the act of breathing. It begins with a mechanism that often goes unnoticed until we feel the weight of the world on our shoulders. You might notice that when you are stressed, or perhaps just before you drift off to sleep, your body performs a specific pattern, a sharp double inhale followed by a long, prolonged sigh. This is known in physiology as the physiological sigh. It is not merely a poetic expression of weariness, it's a hardwired biological reflex designed to mechanically reinflate the tiny air sacs in your lungs called alveoli. Over time, as we breathe shallowly, these sacs collapse like deflated balloons, trapping carbon dioxide in the bloodstream and triggering a subtle sense of suffocation that the brain interprets as anxiety. That instinctive double inhale pops the alveoli back open, increasing the surface area of the lungs, while the long exhale offloads the buildup of carbon dioxide. It acts as the body's most efficient real-time reset button, a lever we can pull voluntarily to dampen arousal instantly. This reset depends heavily on the geometry of the torso. Most of us, when rushing through the day, revert to shallow chest breathing. This limits the diaphragm, that large parachute-shaped muscle sitting at the base of the rib cage. When we breathe only into the upper chest and shoulders, we are signaling to the brain that we are in a state of high alert, effectively keeping the sympathetic nervous system, the fight or flight response, locked in the on position. Conversely, engaging the diaphragm pulls air deep into the bottom of the lungs, physically massaging the organs and telling the brain that the immediate environment is safe. There is a fascinating synchronization happening here called respiratory sinus arrhythmia. Despite the complex clinical name, the concept is a beautifully simple dance between the heart and the lungs. Your heart rate is not a steady metronome, it flows in a wave. Every time you take a breath in, your diaphragm moves down and your heart rate naturally speeds up. When you breathe out, the diaphragm moves up and the heart rate slows down. This variability is actually a healthy, resilient nervous system. Have you ever noticed this subtle shift in your pulse when you lie very still? Let us know in the comments if focusing on this internal rhythm helps you find your center. This interplay reveals a biological cheat code for calming the mind. Because the inhale is linked to alertness and the exhale is linked to relaxation, you can hack your nervous system simply by extending the duration of your exhale. Making the out-breath significantly longer than the in-breath directly stimulates the vagus nerve. This triggers the release of acetylcholine, a neurotransmitter that acts as a natural tranquilizer, slowing the heart and lowering blood pressure. The route the air takes matters just as much as the rhythm. Breathing through the nose does something mouth breathing can't. The sinuses are lined with cells that produce a molecule called nitric oxide. As air passes through the nasal cavity, it picks up this gas and carries it to the lungs. Nitric oxide is a powerful vasodilator, meaning it widens blood vessels and improves oxygen circulation efficiency by nearly 20%.
It effectively sterilizes the incoming air and prepares the body for deep rest. Mouth breathing bypasses this natural pharmacy, often leading to lower oxygen uptake and restless sleep, keeping the body in a state of subtle chronic stress. Understanding this biological machinery allows us to move from automatic reflexes to conscious control, bridging the gap between physical biology and the mental landscapes where anxiety often takes root. To navigate these landscapes, we turn to the science of mindfulness, a concept that has successfully migrated from ancient monasteries to modern MRI laboratories. While often mistaken for the act of simply emptying the mind of thoughts, mindfulness is technically defined by neuroscientists as the act of paying attention on purpose in the present moment and critically doing so non-judgmentally. This specific type of attention is the antidote to a very specific brain function known as the default mode network. When you are not actively engaged in a task, when you are waiting in line, trying to fall asleep, or driving a familiar route, your brain does not simply power down. Instead, it activates this network, which is the neurological seat of daydreaming, self-reflection, and, unfortunately, rumination. The default mode network is a time-traveling system, constantly pulling your awareness into the past to replay regrets, or projecting it into the future to simulate potential disasters. Studies using functional magnetic resonance imaging reveal that for those suffering from anxiety, this network is hyperactive, like a car engine stuck revving in neutral. Meditation and mindfulness exercises function as a manual switch that deactivates the default mode network, quieting the neural chatter and bringing the brain back to the immediate sensory experience of the here and now. This practice does more than just alter brainwaves temporarily. It changes the physical structure of the organ itself. Research out of Harvard Medical School has demonstrated that consistent meditation leads to measurable changes in gray matter density. After just 8 weeks of practice, the hippocampus, which is responsible for learning and memory, becomes denser, while the amygdala, the brain's primal alarm bell that triggers the fight or flight response, actually shrinks in volume. This structural change correlates directly with a reduction in reported stress levels, suggesting that we can literally reshape our biology to be more resilient to anxiety. Understanding the biology of emotion reveals the fascinating 90-second rule, a concept popularized by neuroanatomists observing the chemical lifespan of a reaction. When you experience a trigger that causes anger or anxiety, there is a chemical process that flushes through your body and completely clears out of your bloodstream in less than 90 seconds. If you continue to feel the emotion after that minute and a half, it is because your thoughts are re-stimulating the circuit, essentially choosing to loop the physiological reaction.
Knowing that the initial physical wave is transient can be incredibly liberating, allowing you to simply ride out the 90 seconds without attaching a narrative to it. To help ride out these waves, therapists often utilize a grounding technique known as the 5-4-3-2-1 method, which forces the brain to switch from the internal chaos of the default mode network to external sensory processing. It begins by identifying 5 things you can see, noting the play of light on a wall or the pattern of a rug. Then you acknowledge 4 things you can physically feel, such as the texture of your blanket, the smoothness of a sheet, or the pressure of your back against the mattress. Next, you isolate 3 sounds, reaching out with your hearing to catch the hum of a fan or distant traffic. You then identify 2 things you can smell, and finally, 1 thing you can taste. By engaging the senses sequentially, this method pulls the mind out of the abstract spiral of anxiety and anchors it firmly in the physical reality of the room. This focus on physical sensation naturally leads us to consider how other environmental factors, specifically the temperature of the air around us, directly manipulate our nervous system's ability to calm down. One of the most immediate and potent ways to access this manipulation is through the mammalian dive reflex, a dormant evolutionary holdover from our aquatic ancestors. When icy water makes contact with the area just below your eyes and above your cheekbones, your body instantly interprets the sensation as total submersion. To preserve oxygen for vital organs, the brain triggers a rapid physiological reset. The heart rate slows immediately, and blood is shunted away from the extremities towards the core. It's a biological brake pedal that overrides the spiraling signals of the amygdala, proving that a simple splash of cold water is not merely refreshing, but a hardwired survival mechanism that forces the nervous system to decelerate. Conversely, the body's internal thermostat is frequently hijacked by anxiety itself, creating waves of heat even in a cool environment. This phenomenon, often called psychogenic fever, occurs because the fight or flight response prepares muscles for exertion by dilating blood vessels and ramping up metabolism. You feel hot because your body is literally revving its engine for a physical escape that you don't actually take, leaving that generated thermal energy to radiate through the skin as a flush or sweat.
We can, however, use heat intentionally to reverse this process. Studies on passive body heating, such as sitting in a sauna or taking a hot bath, show that the warmth mimics the sensation of social closeness and safety, triggering the release of serotonin. Furthermore, the body releases dynorphins, chemical cousins of endorphins, in response to the heat stress, which results in a profound chemically induced relaxation once you cool down. This desire to manipulate our environment for comfort brings us to the architecture of our bedding, specifically the science behind weighted blankets. While warmth is soothing, it is the heaviness that engages a principle known as deep pressure stimulation. The consistent weight distributed across the body stimulates the proprioceptive system, giving the brain precise information about where the body ends and the world begins. This specific type of pressure creates a sensation similar to being held or hugged, which naturally reduces cortisol levels and boosts the production of melatonin. It essentially tricks the autonomic nervous system into shifting from sympathetic arousal to parasympathetic restoration. It is fascinating that a mind prone to such intense physical responsiveness and hyper-awareness of its environment is often the same type of mind that possesses a distinct, powerful capacity for imagination, leading us to the undeniable link between anxiety and creativity. What is perhaps even startling is the phenomenon of emotional contagion between species. Because our biological systems are so deeply entwined, your dog can quite literally smell your anxiety. The human body releases specific chemosignals in sweat when cortisol levels spike during stress, and the canine olfactory system, which is tens of thousands of times more sensitive than ours, can detect this chemical shift instantly.
This means that before you have even frowned or spoken a word, your pet knows you are anxious, and often they will absorb that stress, becoming agitated themselves in a silent, sympathetic loop. If you have ever noticed your pet acting differently when you are going through a difficult time, tell us in the comments how your animal companion responds to your own emotions, as this cross-species bond is one of the most fascinating areas of modern study. This biological bridge works in reverse as well, providing the scientific basis for emotional support animals. It is not merely about companionship, it's about a synchronized chemical release. When you stroke a dog or a cat, studies show that both the human and the animal experience a simultaneous surge in oxytocin. This bonding hormone acts as a powerful brake on the stress response, lowering blood pressure and heart rate for both parties involved. We have also learned to treat anxiety by observing how animals respond to physical sensations. The concept of the thunder shirt, a vest used to calm dogs during storms, relies on deep pressure stimulation. By applying firm, constant pressure to the torso, the vest shifts the animal's nervous system from a fight or flight sympathetic state to a rest and digest parasympathetic state. This is the exact same physiological mechanism that makes swaddling soothe a crying infant or weighted blankets calm a restless adult sleeper. These shared biological realities remind us that the roots of anxiety run deep into our evolutionary history, beginning not just in the wild, but in the earliest developmental stages of life itself. As we emerge into the world, one of the very first indicators of a healthy, developing brain is, paradoxically, the arrival of fear. Around the age of 8 months, an infant who was previously happy to be held by anyone will suddenly develop stranger anxiety. This is not a step backward, but a giant leap forward in cognitive architecture. It signals that the child has developed the capacity for memory and object permanence, understanding that their safety is tied to specific people who are currently absent, transforming a vague world into one of distinct attachments. As the child continues to navigate this new reality, they rely heavily on a process known as social referencing, effectively outsourcing their threat detection to their parents. If a caregiver flinches at a spider or tenses up during a thunderstorm, the child's brain instantly encodes that specific stimulus as a survival threat. This is how anxiety is learned through observation, passing silently from one generation to the next through modeled behavior rather than spoken words. Counterintuitively, one of the most effective ways to buffer a developing brain against future anxiety is through what researchers call risky play. When children are allowed to climb trees, balance on high ledges, or engage in rough-and-tumble games, they are intentionally inducing a state of physiological arousal. By navigating this self-imposed fear and realizing they remain safe, they are physically conditioning their nervous system to regulate stress, building a resilience that safety-proofing simply cannot provide. I wonder if you recall a specific moment from your own childhood, perhaps climbing a tree or exploring somewhere prohibited, where you felt that distinct thrill of fear mixed with excitement. Do share that memory in the comments below. As this phase gives way to adolescence, the brain begins a ruthless renovation process known as synaptic pruning. During the teen years, the amygdala, which drives emotion and fear, is fully active, while the prefrontal cortex, which handles logic and emotional regulation, is still under construction. This biological mismatch creates a window of heightened sensitivity where social rejection is processed by the brain using the same neural pathways as actual physical pain. It's a turbulent era where the phenomenon of the imaginary audience feels constantly present, making social anxiety a near universal experience during development. Yet, while these environmental factors sculpt our responses, there's a fundamental hardware component at play, leading us to the biological blueprints that determine why some of us are naturally more anxious than others. Deep within the double helix of our DNA, researchers have uncovered that anxiety possesses a distinct genetic signature. Current scientific consensus estimates that the heritability of anxiety disorders hovers somewhere between 30 and 40%. This suggests that while we are certainly not exact clones of our ancestors, we do inherit a baseline sensitivity,
a set of neurological starting conditions that make some nervous systems naturally more reactive and vigilant than others.
However, possessing these genetic markers is never a guarantee of developing a clinical disorder. Rather, it is akin to being dealt a specific hand of cards that you must then learn to play within the unique environment you inhabit. This intricate dance between our static genetic code and our fluid life experience is the realm of epigenetics, a fascinating field revealing that our DNA is not a fixed destiny written in stone. External factors, ranging from the nutrition we receive to the amount of affection we experience in early childhood, can chemically tag our DNA. These tags act effectively like a dimmer switch, turning the volume of certain anxiety-related genes up or down without changing the underlying code itself. Imagine the genome as a vast library of instruction manuals. Epigenetics decides which manuals are opened and read aloud and which remain closed on the shelf. This explains why identical twins who share 100% of their genetic material can grow up to exhibit vastly different emotional temperaments. Beyond the code itself, our biological hardware is influenced by the internal tides of our hormones. We know that fluctuations in estrogen and progesterone can significantly modulate the sensitivity of the brain's fear centers. Progesterone, for example, often acts as a natural sedative, binding to the same receptors in the brain that anti-anxiety medications target. When these levels drop naturally during hormonal cycles, the brain temporarily loses a biological buffer, leading to heightened feelings of unease or vulnerability that have purely internal origins. Perhaps the most compelling evidence of genetic anxiety is found in the COMT gene, often playfully referred to by geneticists as the warrior versus worrier gene. This specific gene variant dictates how quickly the body produces an enzyme that clears dopamine from the prefrontal cortex. Those with the worrier variant have a slow-acting enzyme, resulting in higher dopamine levels. While this abundance makes them more prone to anxiety and stress under pressure, it also grants them superior memory, sharper focus, and better complex planning skills during calm moments. In contrast, the warrior variant clears dopamine rapidly, allowing these individuals to remain cool and functional during immediate danger, though they may lack the cognitive depth of their anxiety counterparts. This trade-off implies that the very traits that cause us to worry are also the ones that help us think deeply, pivoting us toward the realization that this biological stress response is not merely a burden, but a complex evolutionary tool with a surprising upside. This upside is formally known in psychology as eustress. Derived from the Greek prefix eu, meaning good, eustress creates a neurochemical environment that promotes resilience rather than despair. It is the revitalizing energy felt before a first date, or the focused adrenaline of an athlete before a race, proving that the complete absence of stress is not necessarily the ideal state for the human mind. This delicate balance is illustrated by the Yerkes-Dodson law, a foundational concept in behavioral psychology that maps the relationship between arousal and performance. Visualize a gentle arch, or a bell curve. At the lower end, where stress is non-existent, the brain drifts into boredom and apathy, resulting in lackluster performance. As the pressure begins to mount, however, we climb the curve, becoming increasingly alert, efficient, and cognitively sharp. The summit of this arch represents the optimal zone, where the nervous system is activated just enough to facilitate mastery and focus. It is only when the pressure becomes excessive that we tip over the peak and slide down into the realm of distress and panic. This reveals that the physical sensations we often fear, the racing heart, the sweaty palms, the shallow breathing, are not inherently negative. In fact, physiologically speaking, the body's reaction to terror is almost indistinguishable from its reaction to exhilaration. The biological signature of anxiety is nearly identical to that of excitement. Research has shown that because these states are so similar, we can sometimes perform a kind of mental alchemy. By simply saying the words, "I am excited," instead of "I am nervous," individuals can often trick the brain into interpreting that surge of energy as a resource rather than a threat. This reframing suggests that anxiety is arguably a form of unguided energy, a compass that points to what matters most to us. We rarely experience deep nervousness about things we hold in low regard. Therefore, the intensity of the feeling is a testament to the value we place on the outcome. Reflecting on this thin line between fear and fuel, I invite you to pause and look back at your own history. In the comments below, please share a time when you felt that nervousness actually helped you perform better, perhaps by keeping you alert and focused during a crucial moment when you might have otherwise been complacent. While reframing is a powerful tool, science acknowledges that for many, the biological dial is stuck too high for thought alone to adjust. This realization has paved the way for a revolution in how we approach relief, guiding us from psychological tricks towards the tangible future of technology and advanced treatment. We are stepping into an era where the therapist's office is being augmented by the digital realm, specifically through virtual reality exposure therapy.
While traditional methods might ask you to simply imagine a stressful scenario, VR places you directly inside a controlled three-dimensional simulation of your specific fear, whether that is a crowded room, a high ledge, or a turbulent flight. The efficacy lies in the brain's inability to fully distinguish between a high-fidelity simulation and reality, meaning the amygdala activates just enough to practice calming down, yet the logical mind knows there is no actual danger. This creates the perfect laboratory for courage, allowing the nervous system to overwrite old codes of panic with new memories of safety and survival, without ever leaving a safe room. Beyond visual immersion, technology is also allowing us to listen to the whispers of our own physiology through biofeedback and neurofeedback. Wearable sensors can now map the microscopic changes in skin temperature, heart rate variability, and muscle tension that precede an anxiety attack, often detecting the shift before our conscious mind even notices a change in mood. Neurofeedback takes this a step further by displaying your brainwave patterns on a screen in real time, effectively turning relaxation into a visual exercise where you control the action on the screen simply by quieting your mind. It is a process of teaching the brain to self-regulate by showing it a mirror of its own electrical activity, turning the abstract concept of calm into a visible, trainable skill. The future of treatment is also moving away from the guesswork of generalized medication toward the precision of personalized medicine and genetics. By analyzing a simple DNA sample, doctors are beginning to predict exactly how a specific individual's liver will metabolize anti-anxiety medications, or how their serotonin receptors are shaped. This shifts the medical approach from a trial-and-error methodology to a tailored strategy that respects the unique genetic architecture of your nervous system, minimizing side effects and finding relief faster. Perhaps the most paradigm-shifting development is the scientific renaissance of psychedelic-assisted psychotherapy. Modern clinical trials using substances like psilocybin and MDMA are revealing that under strict professional supervision, these compounds can temporarily quiet the brain's default mode network, which is the neural circuit often responsible for excessive rumination and worry. This temporary biochemical reset appears to open a window of extreme neuroplasticity, allowing patients to revisit traumatic memories without the attached carer, effectively untying emotional knots that have been pulled tight for decades. As these scientific veils are lifted, the cultural conversation is shifting alongside the data, transforming anxiety from a stigmatized secret into a widely understood facet of the human condition. We are moving toward a world where mental maintenance is viewed with the same neutrality as physical exercise, acknowledging that an anxious brain is not a broken machine, but simply a highly sensitive instrument that occasionally requires recalibration. This recalibration begins with a profound shift in perspective, moving away from resistance and toward what psychologists call radical acceptance.
This does not mean resigning yourself to suffering, but rather acknowledging the presence of anxiety without judging it as a failure. It is the vital understanding that fighting the current exhausts the swimmer, while floating allows the water to carry you safely to shore. We have journeyed through the intricate biology of the amygdala and the ancient history of human survival, discovering that the racing heart and the worried mind are not signs of a broken self, but the signature of a deep evolutionary protection system that simply cares too much. You now possess the knowledge that anxiety is merely a biological event, a temporary surge of chemicals that has a specific beginning, a middle, and an inevitable end. It is not a permanent state of being, nor is it your identity. Just as a storm passes over a mountain, leaving the rock beneath untouched and eroding nothing of its strength, these feelings will pass through you, leaving your core self resilient and unchanged. It is comforting to remember that your sensitivity is also your greatest strength. The same mechanisms that cause worry are often the very same ones that allow for deep empathy, creativity, and a profound connection with the world around you. But here, in the sanctuary of the night, those mechanisms can finally stand down. The vigilance that kept your ancestors alive on the wild plains is not needed in the comfort of your bed. You can thank your brain for its hard work today and gently let it know that the watch is over. There are no threats here, only the soft weight of your blankets and the steady, calming rhythm of your own breathing. If this exploration of the mind has helped you find a moment of tranquility, please consider subscribing to our channel for more soothing journeys into science and sleep as we continue to uncover the facts that help us rest. As you drift closer to the edge of dreams, carry with you the certainty that you are functioning exactly as nature intended. The body knows how to heal, the mind knows how to quiet, and you know deep down that you are safe. Let the facts fade into the background now. There is nothing left to analyze, nothing left to solve, and nothing left to do but rest.